And this point is also called the equivalence point. So this is the point at which A has completely reacted with B. So today we are going to start with number 1, neutralization reactions. Reactions. We are going to take an acid, we combine it with a base to give us a salt and water. Then we will take an acid also, and we take a carbonate. And that is where now we are going to start. We are going to allow Mheshimiwa to take the acid HCl and place it in a burette. And then we titrate against sodium carbonate. So the sodium carbonate will be in the pipette, while the HCl will be in the burette. So we want to see now Mheshimiwa doing the experiment. He will put the acid, and the acid in this case is HCl. First he clamps the burette. Let us see how it should be done. Remind them the graduations facing you.
So you place your conical flask, then place your burette just slightly at the tip of the conical flask. Then the graduation should face you as you are doing your practical. The graduation on the burette. Graduations are the marks, are the marking. So ensure that it is firm, not too tight because you may break the apparatus. That's fair. Then after that, at least it can slightly move. Okay, good. Then after that you fill it using the HCl. Be careful with the acid because it is very corrosive. So you lift the funnel slightly up so that you allow the atmospheric pressure to fill it. Oh, okay. It's okay. Then after that class, you release, because as we can see, we have our burette. Then this burette is filled up to this level where the tap is. Then you release some of the titrant, which is inside the burette. You release it a little bit so that you fill the whole burette. So I will release it. I will release it here.
We don't have a lab. This is a makeshift.
Yes.
So this is why we have. You can improvise. Very necessary to improvise.
Okay. Then after releasing that, to ensure this is firm. So back to you, Mwalimu.
Yes. Then from there, you ensure that your conical flask has nothing. Then Mheshimiwa will pipette. Mheshimiwa will pipette the base, that is sodium carbonate.
You open the sodium carbonate.
And then the indicator is methyl orange.
So from here, kindly release the air So what we did first is to clean all our apparatus with distilled water. Then after that, just press here on the pipette to release the air, remove the airlock. Then you put the pipette inside the sodium carbonate. Then you hold it from here. Then you press this part of the pipette to fill it, to suck. So you press it so hard, you will find that you will be using a little force, so you need to eat so much ugali or nyoyo. Nyoyo is githeri in my language, or mokimo.
Yeah.
So you feel it. When you see that it's taking some little time, again release here. Then you press simultaneously. Then again, you feel it, you feel it. You press hard, use a little energy. Make sure you pass the mark. Then after that, release up to the mark. You release up to the mark, and then you make sure you read it perpendicularly. So ensure that you are careful when handling this. So you release using this side of the pipette. Slowly. Then you read the bottom of the meniscus. There you go. So that's our 25 milliliters. Then after that, in a clean conical flask, you release. So you just press it, you release it inside the conical flask.
Then note that we will be adding an indicator. Why did we choose methyl orange in this case? A strong acid, and a strong acid, we can use any indicator. I say that again. A strong acid reacted with a strong base, any indicator would work. But a strong acid with a weak base, we use methyl orange. It is the most appropriate indicator. Yes.
So before you put your indicator, you'll realize that your pipette has some solution remaining. So ensure that you don't, because when you press it, you shall have released everything. So just knock the tip of the pipette along the on the flask, on the conical flask. Then after that, you don't worry about the solution remaining because it has been taken care of. So here you put 2 to 3 drops.
In our case, we put 2 drops.
So you put 2 drops. That is first drop, second drop.
So class, you now see what Mheshimiwa has done. We have a different color here. So when this color changes, but after learning from the burette, then we will have the end point. Now, in this case, how do we record that? We record our readings, our values, in titrations in a table, tabular form. The table here, you will realize that we have from the burette, we have the reading that we have today, what he is starting with. That is the initial, and this one's initial burette reading in centimeters cubic. And read for me.
Here we have 1.5678, 1.8 ml.
1.8. And when you are doing it in class, you do it in pairs to help your skills. So like what he has done, then I would go, if you are working together in class, the way you should do, then if he has said it is 1.8, you don't believe him, you don't trust him, you now confirm. You confirm. And this one I have confirmed. It is 1.8. But in case you find it is, that solution, it is in between here. you can approximate that one to the nearest, to 5 or to 0, to the nearest 5 or 0. So that reading could have been either 1.80 or 1.85, but cannot be 1.82 or 1. So the second decimal point, note in titrations, we always give to 1 or 2 decimal places. Now, if it is in the second decimal place, this one should either be a 0 or a 5. But this one cannot be a 2, a 3. For instance, we can talk of 1.80, 1.85, but we cannot have 1.86, for instance. This will be wrong. So in my initial, before he even starts, I indicate here 1.8. You can have 1 decimal place, but if I like in my case, allow me to use 1.80. Then we allow him to run, and we see.
So from here, you notice that we have a different color here. So let's run it, we see. I want you to look at what's happening here. So you run as you shake it. You release as you shake. So you notice that there's some color change, a little color change. It's turning to a different color, which is pink. There's no color like pinkish, so it is pink.
So you notice there is a change. That is what we'd be expecting.
So there's a change that is coming in. So from there, if you notice that the change is becoming conspicuous, you just release the tap in to release the droplets, not just as a whole, just droplets. Until you get the full color, what to expect is pink, as you can see. So this is okay.
Now you can now see we have this. Let us make the readings.
So our reading here is 29.2. 29.2. Remember to be very careful.
29.2. If you're in pairs, you confirm. 29.25. 29.2. So 29.25 according to. So let us use mine. So this is the first. That exercise, we said that what is here is a titrant. So what we have here is a titer, and the process is therefore titration. This one from the burette is a titrant, and we are analyzing what is in the conical flask from the pipette, which is the analyte. So we do the subtraction. This gives us 5. This 12 minus 8 is 4. This is 8, we carried 1. This is 7, 27.45. 27.45. Now, in this case, assuming we need to take another titer, that is the second one. Now here there is something that you must realize, that our burette goes all the way up to 50. So assuming the next one we take 27, 27.45 plus another one, 27.45, this gives us 0, 9, 4, and this is 50. So 54.90, and our burette as you are told by Mheshimiwa, is at 50. So we cannot use this one as our initial. So we take our solution, the acid, and fill the acid and then put it in the burette so that we carry out another titer. We want to carry another titer so that we are consistent. So this is what we are calling titer. Titers. Titrant reacting with the analyte. From the burette, titrant. From the pipette, analyte. And therefore, what we get here is a titer. And the process, once we repeat that, we get another second titer. So this process is therefore also called titration. So we again allow what Mheshimiwa
from there,
give me.
Do away with the first solution, and then you rinse.
It's okay.
Rinse your conical flask. Then again, use your pipette. Get another solution of sodium carbonate. Hii nataka ugali kweli. This should take you at least just a minute. Then after that, you release it up to where the mark is. Good. So release it inside the conical flask. Or if you want it to go faster, you remove the pipette sucker so that the atmospheric pressure can act on it. The pipette filler. Once again, when it starts doing that, you just tap the sides of the flask. So we'll move a little bit faster to save time. Then before that, we read our initial value. Our initial value is 2.5. In 2 decimal places is 2.50. Then again, we release it. 2.50. So our estimation should be around, what we should be getting is around 27. So if you add 27 to 2.5, so we'll release it up to around 29 there. 29.95, which is around 30. So you just release it up to around 20, and then we start going slowly.
Indicator. Wait.
Oh, 2 drops of the indicator. Okay. Okay, then release.
Those mistakes are common in cars where you forget the indicator. In case you forget, how do you remember? When you see there are no changes, that your solution is again colorless, note that there is a mistake you've done. So you don't move, don't continue. But again, don't panic. If that happens, then you continue.
So you release it slowly, just on droplets. There you go.
Read.
So here we have
29.5.
29.5.
So our readings here is
29.5.
29.5. So that gives us what? 7.
2.
27.00. So you can see from here that there is a very great difference, meaning we need to be more accurate. So if you find you are differing by this margin, then it is important that you check a third tighter. A third tighter will mean you rinse. You don't have to rinse, just endelea nayo.
Okay.
So we work with it like that. We suck again for our third tighter. So we are going to refill. If we start from here, we say 27, we add to what we have now, that will be 54. So we'll need to add.
Okay.
So we need to use the burette volumes. We adjust the burette volumes so that our initial will accommodate something to do with 27.
Then we get sodium carbonate.
The initial reading is about 6.00.
There. Okay. Then you don't forget your indicator. So 2 drops. It's 6, huh? So just release it to around 30.
Left you. Drop by drop.
Now after that you release it drop by drop.
33. Oh, sway yourself. Iko sawa.
Okay.
reading there.
This 33.1.
But 3.10. This is 0, 1, 27. So you can see these two values, they are very close. They are within 0.1 difference, unlike this other one. So in other words, this our initial reading was very inaccurate. So in this case, you only average. Here you average the volumes within plus or minus 0.2. So the ones that are within that is this and that. Now, where do we move from there? From there, we now work out what that one means. What is the interpretation? We have our sodium carbonate. We are combining it with hydrochloric acid. This gives us sodium chloride plus water plus CO2. Then state symbols. This is a solution. This is another solution. This is a solution. This is a liquid, and that is a gas. Then you balance it up. In balancing, we get that. We get that. Now from there, we are saying we have our readings. The first one was 27.45. The other one was 27.00. Then the other one was 27.10. So these readings, we cannot average the three. We can only average this one and this one. So the average reading is 27.0 plus 27.10. And because there are two, we divide by 2. Now in this case, we are going to get 27.05. Now this is centimeters cubic. So we have our equation, and this is now where we come in. When you are doing your titrations, nothing changes. This is what was in the burette. No, this was in the pipette. And this one was in the burette. So you have the two written like that. The solution in the burette and the solution in the pipette. What was in the burette? The average reading. So the volume here is 27.05. The volume here from the pipette is 25. Now, this is your practical is over. What is remaining now is the mathematics and the question the examiner will ask you. For instance, in this case, if we knew the morality here, the morality, let's say, in this my case, was given as 0 for the acid, was 0.11 molar. This was HCl. So the morality here is what we don't have. Remember previously, we worked out this one in different ways. And one of them was MA VA over MB VB, giving us A over B. Now, our molality here for this one, take this one to be your A, this one to be your B. Doesn't matter. So this is molality is 0.11 times volume is 27.05. All this we divide it by molality of B times the volume of B would give us A is the mole ratio. This is 1/2. So cross multiplication gives me that this is 0.11 times 27.05, this one, times 2. All this divided by 25. That will give me molality of my B, which happens the one that was in the burette, that is the molality of sodium carbonate. Just use your calculator, and work out that one. That one you can easily work out, and so on. So that is one question the examiner may ask you. The examiner may ask you to get the molality of a solution that is not known. A solution whose concentration is known is called a standard solution. That it is known concentration. Now, if you have one that you don't know, now the process of looking for the concentration is called standardizing. So in this case, in our case for the sodium carbonate, we have standardized sodium carbonate. I say that one again, class. We are saying a solution whose concentration is known is called a standard solution. So the concentration of the acid was given to us, and that made it a standard solution in this case. Now, the solution that we don't know its concentration was sodium carbonate. We have used the volumes, the titrations, to determine the concentration, and therefore we have standardized. That is one question you could be given. The same question could be given like this. The examiner could give you a carbonate that is not known, and you are combining it with HCl, meaning he has given you the formula of the carbonate. And in this case, he has told you that this carbonate we dissolved. You dissolve 5.3 grams of the X carbonate in water and make it to 500 mLs mark. So in our case, we were using a 250 ml flask. Now we could be given the same question but differently. Now in this case, we are saying 5.3 grams dissolved in 500 mLs, and we are reacting it with HCl. So what would be the equation? X combining with this, XCl. Looking at this, this tells me that the charge of X is 1, is monovalent, plus water plus CO2. So if I balance my equation, that is what I get. So this is what is in the burette. This is what is in the burette. Let us now have burette here, and let us have pipette here. My volumes in the burette would be, let's say, here I take 26.7, 26.7. So what is the exercise here? The examiner is now interested in working out this. We work out the mass of this. After we work out the mass of this, we'll get the mass of X. So whatever, these are theoretical values. So in this case, I got 26.7, 26.7. So I will average all of them. And therefore, the volume in the burette is 26.7 centimeters cubic. The volume in the pipette has not changed. This is 25.0 centimeters cubic. What other information was I given? If I know the mass that was here, and I know the mass that is here, and I know something to do with the, let's take the molarity of one of them. And this one could be 0.187 moles per liter, or simply molar. So with this information, I can work out this. In an exam, you don't have to know the carbonate. So what do I need to do? Here, I will have to use the same formula that we talked about. MAVA over MB VB, and this is A over B. So morality here of the first one is what I don't have. The first one here, I don't have this, so I can work it out. But I have everything for this other area. So this is what I'll do. MA is not known. Volume is 26.7. Confirm, 26.7. So you divide this by 0.187 times. The molarity, the volume here was 25. The first one was this carbonate, so 1 over 2. So here is 1 over 2. So again, class, it is very, very simple for you to work out that. It's a matter of cross multiplication, and you are home and dry. This is 0.187 times 25 divided by 26.7 times 2, you get the molarity of whatever you didn't have, which was the base. That is the next question. The same examiner may give you another question. And this question is, you take a carbonate, you react it with an acid, say HCl, then you will get a salt plus water plus CO2. And then, that is what you, then this acid, you are given some solid, this is solid. Then you are told to put it in an acid and stir. Then you are told from there, you take the solution so formed. In this case, it is the excess acid. Then you take the excess and add water to it. This one you dilute a bit. Then whatever you get here, you know this is diluted HCl. So this is the same question, class, where you are taking now a carbonate, reacting with an acid. Then the excess acid you take, you fetch 100, say, you dilute with water. Then you titrate using sodium hydroxide. So the titration is not all this. The titration is this part. But once you work out this titration, you know the molarity of this and the volume from the pipette. Then this becomes the burette reading. You can get the concentration of HCl. this concentration, you had this concentration was of the dilute one. So you can get the concentration of the acid that was not dilute, and you will get the moles. Those are the moles that was in excess. Now, those moles that were in excess were the ones that reacted. So you subtract from here, you get the ones that reacted with the carbonate. And that process where we are working back is what some books would want to scare you by calling it back titration. Now, before we work out a question on back titration, I want to invite our MP here to take another reaction of a direct neutralization, direct titration that doesn't involve a lot of working. This is where we are going to take an acid, and this is sulfuric acid. We combine it with sodium hydroxide, and we see what we are going to get. So he has already rinsed this. So in the burette, we'll put the acid. In the burette, we'll put the acid. So tuweke mpaka hapo, then from there we are going to see the other one. We used methyl orange. Now this is a strong acid and a strong base. We can use any. So this one we're going to use phenolphthalein. So we change the indicator and we use phenolphthalein. That one is where? This one. So we want to see now how we work now with phenolphthalein. Remember, you are promised, Mheshimiwa, we can create a bomb. It's possible.
Yeah, this is a laboratory. We can manufacture a bomb here, but not for destruction.
Huh? Let's see what happens here. You've not taken lunch, man.
I'm really I need to eat more. I need to eat more ugali. Okay, now good.
Then you release it.
Shikilia mpaka isi. This is ilikuwa ngapi? Hii ilikuwa ngapi?
11.5.6.
So the initial reading 11.6.
6.55.6.
11.6. Sawa. Akajaisha. Wacha kaisha.
Then 2 drops of phenolphthalein, or 3 drops. 1, 2,
3. So this time round you can see we are starting from a pink color.
So the first titer amesema it was 6. It's okay. This is the volume. That is the final readings. This is initial readings. This is the volume used in centimeters cubic. Continue.
No, I did not release it. So I release faster.
So we start.
So our first value changes because we did not release it.
The first one changes.
It changes to 12.567
12.8. 12.8.
We did not release it, yes.
Fine. Let's move on. This is the first titer we are doing. So we'll take another one so that we are consistent.
So mostly the first item normally is to know how you are going to move next so that you are consistent.
Yeah, sir. Final reading?
25.
25.
Yes.
Social distancing? 25.0. 25 points?
0.0.
0.0. So that gives me, here there will be 2, 4, 8, 18. Is that correct? This is,
This is 2.
Oh, this is 2, yes.
Yes.
This is 2. 12.2, correct. 12, so we can start with the same 12.2 as our initial. Don't rinse, Kosatu. We suck again. So this is our second titer, titer number 2. Or you can simply call it second titer. This is the first titer. These are the titers. And therefore this is titration. And this is volumetric. Big name to scare you, but little stuff. Itafanya mbili. Gari kagumu kakitu. Very nice, very nice.
Okay, then the indicator, 3 drops. Okay. Then we release it.
Shake. Drop by drop.
Okay. So that's 37.1. You be careful as you read. 37.1.
37.10 if you want. The second decimal point we said can be a 0 or a 5. So this is 11 minus 2. That is 9. And this is what?
This is 6, 4.
This is, we carried 1, 6, 4. And this is what? 2, 1. 14, meaning we can't have values like this. What does that one tell us? It is important that we look at a third title. We have been very inaccurate in that case. Here we cannot differ. They can't differ by this much. In an exam, if you ever found this kind of a situation, that tells you you are wrong. You've made a mistake in one of the two. So we now see what happens with the third title. And this is why it is important, therefore, to avoid these mistakes. We are doing this one to show you some of the things that you do. But when you do this, it's an indication that you are wrong. So how do you avoid this? From the word go, when you are starting, you ensure that you rinse your apparatus carefully and you run your solutions from the start, drop by drop. Let us now see what we do with this other one. That's 7, 40.
Sorry.
So you be very careful, class, in rinsing your apparatus because it might affect your next practical. So some of these things we decided to do the second practical to let you know how you need to move on to be accurate, because if you just do it, you will find very big values, difference in values. So we are doing this also intentionally to explain to you such that when you find different values with value with different variations, then you see how to work it out.
So our initial reading has changed.
Okay.
Soma the initial kwanza. Wacha na soma kwanza.
Now the initial value, the graduation is 14.123. 14.3. Now you put 3 drops.
Yeah. So we need to go 29.3.
So
I've made a mistake.
no, it's okay.
No, this one.
Then
This one. This
is
two,
9.
This is 2.
yes, so this is very big variation. Yeah.
This is very big. So it can't be. It can't be like this. It can never be. So 6.5.
Sorry.
There.
Change.
It's changed. So that's 26 point
26 point?
0.6.
26.6. let's see, 26.6. So that is 0, 3, 2, 12. So, class, in this case, let us see which of these three is correct. One of these values is not correct. In this case, you find that this your readings is almost double these other two. This tells you that this reading is inaccurate. It can never be. So when you are in an exam, you don't simply remove it. But when you're doing with your average, you deal with those values that are plus or minus 0.2. So you discard this. And therefore you get 12.20 plus 12.30. This one you divide by 2. And this gives you 12.25 centimeters cubic. Now, these are the values that we have. Let us see what happens now in an exam. In an exam, what will the examiner do? Here you have your sodium hydroxide. You are combining it with sulfuric acid. Then this is going to give you sodium sulfate plus water. Now in this area now, you put the state symbols. And this is a soluble salt. The next thing, you balance it up. 2 here, and therefore 2 there. Then you have your line. This is all what will happen. So here you have the pipette values, and the pipette in this case was 25.0 centimeters cubic. Then this was the volume of the burette. This gives you the average, 12.25. The value, was it 12.25? What was it? 12.25, correct. Now this is centimeters cubic. Then we have morality of your solution B and morality of your solution A. Now in this case, what were we given? We were given the morality of the acid, and this is this, and this is 2 molar. The morality of the base, we don't know. So we put a question mark there. Then mole ratio here is 2. Mole ratio here is 1. Yes, 1. So where do we go from there? We can use the formula that we have. MAVA over MBVB should give us, remember we demonstrated how we got this class. So MA here is very simple, is what we don't know. VB is 25. We are multiplying by, we are dividing by 2 molar times VB is 1. We should get A is 1 over 2. Because VB here, the volume here is 25. Morality here, this is MA 25, this is 2 molar. Volume here is 12.25. So what do we get here? MA should be equal to 1 times 2 times 12.25. Then this other one, we are going to get 2 times 25. And therefore this 2 goes, this is 12.25 divided by 25. And then, because I don't have the calculator, you can finish up that. You can finish up that, you put it in your calculator. Now next in our course here is that you can be asked very many things by the examiner. The exercise remains the same. The examiner may choose not to give you the acid. So the examiner may tell you, you are reacting a base, and this is solution P, which is sodium hydroxide, and whose molality is given, say here 0.2 molar, and the volume you know from the pipette, from the pipette is 25. Then you've been given a diabasic acid. The acid could not be given. You are given this is an acid, solution Q. I just want to show you how the examiner will play around with your brains and confuse you, but it is very simple. I may choose not to give you the acid. So I tell you this acid is solution Q. Solution Q is prepared by giving us from the acid. So this diabasic acid. So this is what you've been, a diabasic acid means that. So when you are reacting that, what do you get? We are saying you have your sodium hydroxide. You are combining it with the diabasic acid to give you the results. And this one, the result should be sodium. This tells you the charge of X, which is 2, plus water. Then you balance it up. How do you balance that? 2 here as the subscript, and that. It's balanced. The equation is like that. All sodium salts are soluble. So I have now this. So the examiner want you to get the LFM of the acid, then get the mass of X, and then you get squared. In this case, it is very simple. Here you will get the MA VA over MB VB over A over B. Once you get, so here what we have the molality there, we have the volume there, we have the molality here we don't have, but we can get that, we have that, we have that. So we get the molality of B, which is this. If we get the molality of this, given the mass or the volumes that were mixed, then we can get the LFM. And after we get the LFM, then we will get the mass of X. And that is how simple that one is. Now, from there, we now move on to what we call redox titrations. Redox titrations. With redox titrations, this is simply a name to confuse you. This is combination of 2 words, reduction and oxidation. When we combine this, we get redox. So we get a strong oxidizing agent. A strong oxidizing agent. And we react it with another substance. And in this case, we'll get a salt plus other products, depending with the oxidizing agent in question. So how do you go about this? Now, some of the oxidizing agents that we have we can have potassium permanganate. We can have potassium dichromate and others. These are the common ones. Remember, these ones are colored. So in the previous exercise that you have seen, Mheshimiwa ametumia indicators tofauti, phenolphthalein and methyl orange. In this case, you will find these are colored. Unlike in the case of the dichromate, where we can use diphenylamine indicator, in the case of the permanganate, we don't really use an indicator. Kwa nini? Indicators are used to tell us the end point. The two products have combined. So in this case, this is purple. Some people like working it like that. So what will happen? So we will take an oxidizing agent, that one, which we have here. Then we will combine, and these oxidizing agents are normally acidified. So hydrogen ions plus, in this case, we're going to use ammonium ferrous sulfate. We are going to, this is going to be oxidized to iron 3. Then this one we are going to get water, and this one we are going to get manganese, 2 ions. Then the next thing is to have state symbols. Then we balance it up. Then we balance it up. My equation is balanced. And what we are going to do, the exercise is the same, class. Don't worry, don't be scared by this. This one, the examiner will call it solution Q, like I have done. This one is solution P and Q. So we have a solution P and a solution Q. This is P. Now, don't even bother with trying to know what they are. As long as you know, or the examiner will tell you what is going to be in the burette and what is going to be in the pipette. And remember, Mheshimiwa, remind them about this part. Remind them.
Now, in this, when you have your burette, remember when you fill your burette, this lower part of the burette from the tap is not filled. So you remember to release, at least to fill it, completely fill it, you release the tap so that the burette is completely full. So let me just do it here, you see. The other time we were using colorless fluids in the burette, so now we have a colored one. So when you release a little bit, you release, now it's full. So you can just release up to even that level. Good. So it's now full. Then you close it firmly, not so tight, just firmly. Yes, so
Now, you can now see why it is important to fill in this, so that your burette does not give you a confusion and your readings should be as accurate. Then from there, we are going to have, this is ammonium ferrous sulfate, which we are combining with, so you pipette this solution. You pipette that solution. So note, we are having potassium permanganate in ion form. You are reacting it with ammonium. To oxidize iron 2 to iron 3, then water becomes a product, and then there will be manganese 2. So we're going to have a similar thing. Here we are going to have a similar table. This is the first titer, the second, and maybe the third, if our solutions allow. We can label them like that. Initial reading. Initial reading.
Our initial reading is 1.2.
1.2. Remember, if you're working together to confirm, this is final or reading in centimeters cubic. This is initial or readings in centimeters cubic, and this is the volume of the manganese used. So, umesema it was how much?
That's 1.2.
1.2 was our initial, 1.20.
So we release.
Yeah? Let's see.
37.
Hmm?
37. So you can see what's happening in the reaction.
Angalia tu chini, angalia tu chini. Endelee. Wacha niingie. Weka mpaka sama hii. Hapa hivi. Then we run. Do it. Now what we are doing with Mheshimiwa is only for demonstration, because you're supposed to do this one yourself. Endelea. Shake tu. Shake mpaka ibadilike tu. You can see it has not changed. You continue, you don't panic. Hivyo. Umeweka mingi lakini sawa. So
That's 37.3.
37.3. Don't panic. Just 37.3. That gives me 0, 1. This is 6, eh?
Yes.
That is 36.0. Now, looking at this,
0.1.
huh?
36.1.
If we make this one our initial, then there will be a mistake, because we can't have 36 added here is 72, and our burette cannot be. So there is need, therefore, for you to refill. You refill your burette. Iko sawa. Tuanze hapo.
So
Our initial reading.
initial reading is 9.1234. 9.4.
9.4.
4.
9.4. We have started with 9.4. Remember again where you are indicating. If you indicate these values in the long boxes, then that means an inverted table. And with an inverted table means that you will be wrong and you will not score. How are the markings done on such a question? One of them is consistency values. If your values are consistent, then you will get a C1. Is your table complete? Do you have the decimals? Is your value interdem with your teacher's value? So already before we go to anything else, look at the distributions of the marks. We are saying consistency in your values, completed table, decimals, and school value. Then there is another mark that we call the principle of averaging. So what we are doing here, we are dealing with a total of 5 marks. Under the 5 marks distributed like that, then this one, your teacher will always work out the values. If your school value, your teacher's value, and your values are within, if you have a single value on your table that is within the, you score. If you have decimals and they are consistent and they are realistic values, you score. Is your table complete? Now, this is how simple it is for you to pass in an exam. For you to pass in an exam, it is not easy. Already this is, these are 5 marks. And 5 marks in chemistry practical. 5 marks, we are saying, that is a lot of marks in any exam. So let us see what the Mheshimiwa is doing here. The initial reading, Msema, confirm
9.4.
9.4.
Yes.
So now work out tuone.
You keenly observe what changes in the reaction.
If you are those people who give up, that you are running too much solution, then you lose it. So you continue. You continue and you are swaying. The reason why you sway is to make it mix, and mixing uniformly. Like you can see, our solution here is mixing uniformly. Drop by drop now, as you shake. Drop.
Good.
So that's nice. So read for me.
That's 45.6.
45?
0.6.
45.6. So 45.60. Consistency in the decimal points. So this gives you 0. That gives you 2. Or that gives you 36. So do we have another solution for another one? Let's confirm. Refill.
Okay.
Refill. We want to see whether we will be consistency.
We are almost finishing class, so just be a little bit patient.
That's okay.
So a little patient, we're almost finishing. This lesson was we have a very long one, but we are almost done. Our students must pass exams.
They must.
There.
Our initial reading?
Initial reading is 0.1, 2, 3, 4, 5, 0.5.
0.5.
5.
0.5. 0.5.
So we release.
Angalia huku chini, ndio angalia huku chini. Release mpaka rudi. Shikilia tu, shikilia tapu hii asishike. Hivi. Now we have realized that we are taking up to around 30, so you can run without shaking. That is what we are doing. But you check here, isivuke 30. So then once you get closer to your values, then you can start now placing it drop by drop. When it gets closer to around, you can see from the first one and second one, you can't go outside 36. So you will be within 36. So if you can now run it through all the way up to around 36 there, you will be home and dry. Then you run it drop by drop.
Yeah.
Like that. So that it has changed. What is the value? The final reading.
36.7.
That 6.7. 36.7.
Yes.
And we said you are working in pairs. When you are working in pairs, you confirm. Let me see. Correct. That 6.7. So you confirm. So that will be home and dry. So this gives you 36.20. Now looking at these values, this and this are within 0.1. This and this, they are the same. So in this situation now, for you to score this mark, then we are dealing with this. So how do you work out that? So for the average, you will say 36.10 plus 36.20 plus 36.20. That one, you are dividing it by 3. This is, if you have a calculator, it will be 36 point what? 36 point what? Let me use my calculator. Let me use my phone. But work it out meanwhile.
0.15, eh?
Yeah?
36.15.
It can't be 15.
Is it?
At 6 points? Let me see. This is 36.10 plus 36.20 plus 36.20 divided by 3. 36 point, fine. 36, and very important, this is 36.1666 recurring. Now, very important here, class, remember, when you get such a value from your calculations, which is very important, you cannot record it like this. You cannot record it like this because these values are from a burette. So you come here and give your answer to 4 significant figures. Now what do I get here? This is 36.17. Now, what does this one mean? Now, this your value, we could not have the second decimal point here being anything else other than a 5 or a 0. However, after working out here, we have got the average of the 3 by dividing by 3 here, and we got 36.166 recurring. So how do we record? In this case, we are going to record that 6.17, and this is the volume. This is the volume you're going to use for our calculations. Now, what does that one mean? Now, in this case, I want to take you now back to the examiner. Here, we didn't balance our equation. We balance it now. Here, we have 5. This is 5. 5. This is 8. That is 4. My equation is balanced. So, we now move on to the next step. The next step again now, we are saying that is manganese 4. We are combining it with acidified ammonium ferrous sulfate. And this one will be oxidized to iron 3 plus water plus what? Plus manganese. Manganese 2. We have said we now balance it up. This is 8, this is 5, this is 5, and that is 4. So we now put our line here. You don't have to worry. In these questions, the exercise is the same. Very simple. So this could be a solution A. This could be a solution B. Here we have discovered that this was always, the volume here was 25 centimeters cubic from the pipette. This is the pipette. Here, this is the average volume because this is the burette. And we have seen that the volume here was 36.17 centimeters cubic. This is your solution A. And the mole ratio, so A here is 5. A is 1. A here, B is 5. So these two are combining in the mole ratio 1:5. Then here we are dealing with morality of A and morality of B. Depending with the information given, here, we can work out here. For instance, the information that we were given by the examiner here is that this burette values were 0.02 molar. So simple exercise, don't worry. It is MA VA over MB VB, and this gives you A over B. MA is 0, MA is this, 0.02. VA is 36.17. Then MB is what we are looking for, times VB is 25, giving us A over B, 1/5. Cross multiplication tells us that we are going to get MB being equal to 0.02 times 36.17 times 5. All this divided by 25. That gives me the morality of that solution. Now take your time, 5 minutes, as I sip water. Mheshimiwa nipe maji. So, and you will get an answer in that case. Very simple. So that we now move from here. We now see what we get. This is very simple from your calculator. Just feed your calculator and get that. Now, where are the questions in this case? Now, note ammonium. Ammonium ferrosulfate. Ferrosulfate. Remember, this is the very complicated sort. A very complicated sort of this. So if the examiner gives you this, then you would think that you will change. You will here 0.14. 0.14 molar. So mark for yourself those who got that. 0.14 molar. Now, what are we saying? Examiner has given you that. What are the likely questions of this? If you see this, then you get scared. But there is nothing to get scared here about. The examiner will tell you things of this nature. One of the questions the examiner will give you, he will give you the sort. Ammonium. Ammonium sulfate. Iron sulfate. Now, then the examiner refuses to give you that. The examiner may choose not to give you N. So how do you go about working out this? You will be told, fine, that an ammonium salt, ammonium, this is a double salt, because it's an ammonium salt, reacts with potassium permanganate. You'll be told it reacts in the ratio. Where it is the permanganate, in the ratio is to the salt. He will not tell you which salt is it. Now, in this case, you have all this. So you will know, you'll be given the ratio here, 1:5. So what does that one tell you? That you have the permanganate is to the salt. Here, this is your A, this is your B. Your A is 1, your B is 5. So if you have the morality, like I can give you some hypothetical values. I can give you some hypothetical values here from your burette. From your burette, I have values here, 31.30, 31.20, and 31.25. These are hypothetical values. So the volume here, the average, is these three. They are all within 0.2. So you divide them by 3. Very simple stuff. So in this case, what do you get? This case, from my workings here, I get 31.25 centimeters cubic. That is the value I've been given. Then from here, what other information am I given? Here, this is the volume. The volume here is, of course, that one of a burette. I mean, pipette. That is the pipette. So from here, I can do very many things here. What other information do I have in this case? Molality here of B. And this is 0.15. I have now that information. So what I don't have, what do I have? Yes, I have something close to that, 0.5. So with this information, it is very, very possible for me. Here I have, I don't have the molality here of A. So MAVA over MBVB should give me A over B. Very simple. So morality of A I don't have. Volume of A I have. Morality of B I have. Times 25. Then this is A over B. So in this case, what am I saying? I'm saying MA should be equal to 1 times 0.15 times 5 divided by 31.25 times 5. Once again, class, you can work it out. That value is easy for you once you get the morality of the sort. Once you get the morality of the sort and you have everything else, then it is very, very possible for you to work out that. The other version of that same question is, we have said once again, this is the formula of the sort. We say ammonium ferrous sulfate, which is a double salt, and also it is hydrated. One, this is a double salt. Double salt in the sense that it has two salts in one. A crystal of this salt has ammonium sulfate in it and iron 2 sulfate in it, and it is hydrated. 6 water molecules. So you could be given that a double ammonium salt has the formula X sulfate, and 6 water molecules. That is the formula you've been given of the salt. So the examiner really doesn't care whether you know the salt or not. And again, you don't have to know the salt. So what does that one mean? That one means that you will still have to do the same. You have your ammonium salt, it's combining with the permanganate. So you have your permanganate here, and you have your salt. The same process. Here you have what is in the burette. You have what is in the pipette. The examiner will not fail to give you information. So you will get the information concerning the morality, concerning the volume. And this one you get, the volumes you get from the burette here. The volume is from the burette. Here you will get the morality. Here you will get the volume from the pipette. So these things work together. The volumes, one will be from the burette, the other one from the pipette. The moralities are what you will be given by the examiner. You will be given one of them. And when you are given one of them, and you are given the ratios, reacting ratios, which I'm calling here A and B. The solution that you write to this side could be A, the what you write to that other side could be B. So here you fill in what you do in an exam. Just have your equation, have what is on the burette, have what is on the pipette, all the information on the solution that you have from the burette indicated there. Then what we are saying, this formula will always work for you. This formula will work for you. And what you've been given here, what you indicate there, then you work out what you are missing by simply cross multiplication and so on and so forth. That is basically what you do in titration. And the other one that I wanted to mention is, once again, remember, we talked about sodium carbonate. As I wind up, reacting with HCl. So you are given a solid, and this solid could be, let me use values that I have worked out, maybe 6.25 grams. You put this one, this solid, in a beaker. This is a beaker. So you put your solid here. Then you put, you are given 100 centimeters cubic of 2 molar HCl. So a carbonate and an acid combines to give you a salt, water, and CO2. So how much of the acid do you have? 2 moles in 1,000. What about 100? So this is 0. This is yeah, let me work it out. 100 times 2 over 1,000. This gives me 0.2 moles. So the moles you are having here are 0.2. So this acid, and here you've been given 6.25 grams. So if we divide 6.25 by the LFM 106, what do we get? We'll get the moles here. Let me, what do you get, class? Mwashimiwa, have you worked it out? 6.25, work out for me. 6.25 divided by 106.
106, that's 6.25 divided by 106. 3.91, 906.
3 point.
Oh, 0.6.25.
6.25.
Sorry, 6.25 divided by
106.
106. 6.25 divided by 106. Okay. 0.0589. 0.0589.
589.
62. Yes.
Oh, fine. So approximately 0.06 moles. Note that if I balance up this, I'll get so if I balance it up, I'll get for every 2 moles here, I need 1. So if I have 0.2, I need 0.4, meaning this is limited, this is a little, so this is in excess. That is in excess. That is what we are saying. So this in excess, in a practical, what will the examiner do? He will not give you this, morality here, because he wants you to find the moles or the concentration of this solution. So how will he paraphrase that question? He will tell you now, you take this, you put it in a solution and stir. So you will get a solution. Then this solution, he will tell you to fetch 100 centimeters cubic of this, or even 50, because it was 100, he tells you maybe 50 centimeters cubic of that. Then he will tell you to add water. So in other words, you dilute. You dilute to say 250 centimeters cubic. What does that one mean? The moles that are here in 50 are the ones that are in 50. Only that we've added water. We've taken here, this is a certain number of moles here, and then we add water. The number of moles will not change. Then I take now this, which is diluted HCl, and then I combine with the sodium hydroxide to give me sodium chloride plus water. So if I now titrate this, this is burette, 25 centimeters cubic. Then this is 0.02 molar. Then I react with this. This one from the burette, this is from the burette, this is from the pipette. So if I take, like say, 10.5 centimeters cubic, how will I work back? So I have titrated this with the diluted solution. So I'll work the moles of this. This is the formula. MAVA over MB VB A over B. So I'll know the concentration of this from this formula. That is the molality of this. Then what are, if that is the molality of this solution, what about into 50? The moles I'll get here, the moles I'll get here are the same moles that are in 50. These moles that are in 50 here, if I multiply by 2, I'll get the moles that are in 100. Such that now these moles will be less, and therefore I can subtract. The moles I'll get here, I subtract from the initial moles. The initial moles were this one. Then I'll get the moles of HCl, and I can work back and see. So in other words, that is what we are referring once again, back titration. So the aspect of back titration, is not that you are working back in doing the practical, but back titration is the backness, the back in working from the front, working to the reverse, to where you started. So you do all this, then this is where you do the titrations, and then you work back, where that is very, very simple. So class, in case you need any clarification on what we've done, maybe Mheshimiwa, you could come close so that we have finished our lesson. If you need clarification on what we've done, we'll give you our numbers. You can write a message, and we will still get back to you. We have sent an assignment to you, which you should be rolling on your should be on your screens, and then you work it out. So Mheshimiwa, back to you.
Thank you very much. Thank you, Mr. Gishui. To me, you are the best teacher ever. I really wanted to talk about this. Class, after making such a beautiful solution, please don't drink it. It looks like juice, but if you drink it, your stomach will burst. Yeah. So thank you very much. Today marks the end of our topic called the mole, and this topic has been perfectly handled by Mr. Gishui, around 99%. I was just handling around 1% of the practical. So Mr. Gishui, thank you very much for assisting our students, and you are the best. Actually, whatever has been done here, and class, please make sure you do revision on this. Make sure you do the assignment. This must come in examination. I'm giving you a leakage. This will be a leakage in exams. So make sure you don't get scared when you're doing the practicals. And may God bless all of you. Mwalimu uko juu kama upstairs the heaven. Uko top kabisa. So thank you very much guys. Nimejua watu wetu wenye wali tune in, mmefurahia with the lesson. Any other issue being discussed is an issue. We pray to the Almighty God so that everything goes on well. Thank you. God bless you all. Asanteni sana. Mungu awabariki. Tialala. So on Facebook, that's Instagram. Farel Nyadera, as a teacher of chemistry from Kabatonjo School, I can say without fear of contradiction that Mwesh has done a wonderful job. Congrats. Nebulas, Mwalimu Babu na Mwalimu Gishui, mko top. Mohit Makadia, the mole concept covered perfectly well. Kondir Luther, Babu cares for our students. This is wonderful. So many comments. This is very beautiful. Njeri wa Kahiga, I know this lady very hardworking and also very beautiful. May God bless you and give you a favor in everything you do, Mheshimiwa. Asante sana Njeri. Pal, mambo iko sawa. Ningependa hata babu anioe bibi wa pili. Ai, hii nitamalizwa kwa nyumba. But thank you for that. Nitakupatia ndugu yangu. Mohitma Makadia, yes, we revise chem this evening, the mole concept. This is wonderful. On Facebook, very fast, let me just check some of the few comments. On Facebook, we have Dennis Madeka, Babu, you are the best. Colin Sondira again. Ai, kwani ulikuwa classes ngapi bwana? Hii ndio kuiba mtihani. Babu, this is wonderful. Hii ni sawa kabisa. Picha clear, nasema Babu ako juu. Moses Maina Kigano. This is one wonderful guy who's been promoting our education also with the he has a company that is doing sales on mobiles and mobile covers, so you can promote him on the gadgets. It's called the Slick Gadgets. Abed Laz Babu Owino, you are the best. Mwingine amesema hapa quick recovery DJ Evolve. Let's pray for DJ Evolve. The Almighty God will help him and he will heal in Jesus' name. For those who are agents of Satan, will continue fighting. So thank you for that comment, my guy. That is Odoyo Munga Senior. We have Dio Diof, continue with the good job. Said Donald, this is proper, I love it. Korir Nelson Mweshi, this is great. Do not fear any intimidation. You are helping our children. Nobody should intimidate you. Mtu anasema nimpatie helmet yangu, lakini hiyo helmet nitakudonatia. Just send nini inbox nikupatie hii helmet. Ibrahim Kainga, students were advised well. Sobe anasema mambo iko sawa kabisa. Sobe Duke, Babu, you are the best. Kelvin Obunga, keep up the good job. Smallin Steve, Babu, mimi ningekuwa na dota wangu ningekupatia. Hey, that is wonderful. So YouTube, on YouTube we have Swale Hassan, this is a great job. Mr. Gishui has done the best. Simon Nyangara, good job Mwalimu, we love your class, keep it up. Dennis Mwema, good job Prof, given my number, and say hi to Mr. Gishui, was my teacher at Alliance High School. He's made me be a doctor now. Wow, Mwalimu unasikia hii mambo iko. Mimi naye nimesoma hizi vitu kwa library, naona mimi naweza tengeneza bomb sasa. Na hiyo bomb itakuwa for future, ina shida. Itakuwa bomb ya love. So Glen Bay, mambo iko sawa, kazi iko sawa. Abdiaziz Ahmed Tibim, Babu, we love you. Scott, Babu, we love you. Julius Mangwana, This is a true leader taking care of future generations. Love you lots, Mheshimiwa. God bless you. Ken Mijungu, Babu, niliona nimepoteza kazi juu yako, but nisamee tafadhali. Nimekusamea ndugu yangu. I love you so much. This is great. Oh, another guy from NTV. Tusamee sisi kama NTV hatukujua. Asanteni sana. I don't want to read all. But God bless you. Na tuseme ni Tibim. Asanteni sana.